Welcome back. Hopefully all you guys are happy, healthy, and safe. We're going to go through random samplings and population inferences today. And so with that, it says here, first off, some random samples. We got to get a definition for that. In order for it to be a random sample, it says everyone in the population must have an equal chance of being selected in order for the sample to be random. So what that means is everybody needs a chance for this to, or needs a chance to be selected. So you can't be like specific and only selecting people that would benefit your statistic. So that everybody needs an equal chance. So down here it says the survey is taken for the favorite sports teams of 7th graders, but only girls are surveyed. And then it says here this is a blank a random survey, random sample, and it's not a random sample. And the reason for that is it's only interviewing 7th grade girls. In order for it to be truly random, it has to survey a random group of people. This population, it's a random group, not just specifically 7th grade girls. Now, if it said that they surveyed just 7th graders or randomly selected 7th graders, then yeah, it would be a random sample because it could be boys or girls. Right, so with that one, we got to read through this information below and we got to determine a couple of things. So, if we look at this scenario, it says the senior class president would like to host an after-graduation lock-in. There will be games, gifts, and food. In order to decide if people will be willing to buy tickets and attend, she's decided to conduct a survey. She will select 25 students to meet and give input on food, prizes, food, and ticket price. There are 25 members of the senior class. There are 500 members of the senior class. Man, I'm off today. Woo-wee! But if I look at this information, I have to determine based on this stuff up here whether or not this is going to be a random sample. So I'm going to go to the next slide so I can see all of my questions. But if I look at this one, it says first off, she selects every 10th student as they get off the bus in the morning. Is that going to be a random sample of the population? Well, first off, no, it's not going to be a random sample because it's only getting people that are on the bus. So I would go ahead and say that it's only including people that are riding the bus. Not every student rides the bus, so that would not be a good indicator to get every 10th student. Even though it was random for every 10th student, not everybody rides the bus. Now, if everybody did ride the bus, that would be a great random sample. All right, number 2, it says she asked the choir director to allow her to survey the choir. Same scenario, this is not a random sample. And the reason it's not a random sample is that it only includes people that are in the choir. So if you're not in the choir, you're not included in that. That means it's not a population, it's just a sample, and it's not a random sample because it's not including everybody with an equal chance. Alright, this next one, it says that she meets with the counselor who selects every 12th student on the school roster. Now, the school roster, that's kind of a weird thing, but that's a list of all the students in the school. So if she meets with the counselor and they select every 12th student on that roster and every student is on the roster, then that one definitely is a random sample because you will randomly select every 12th person and everybody has an equal chance of being selected. All right, number 4, she assigns assigns each senior a number and randomly selects 25 numbers. So if they were to all be given a number and they were to be selected 25 of them, everybody has an equal chance of being selected, so that means that has to be a random sample. Number 5, she makes an announcement that people interested should meet in the library after school. Now, at first glance, that one sounds really like a really good option, and it does seem like a random sample because you don't know who's going to show up. But with that being said, it's not a random sample, and the reason it's not a random sample is only the people that are going to volunteer are going to show up. There are some individuals that they might have great ideas, but they're not going to volunteer. If they're assigned or told to do it, they'll do it, but they'll not volunteer that information. So that's why this one's not a random sample, because only people that are wanting to volunteer will participate. And then number 6, a roster of the senior class is printed, and each student's name is put into a hat, and the principal selects 25 names. So if we look at that one, Again, they're getting all of the senior class, they put them in a hat, and they select names at random, and that one makes it a random sample. Okay, so hopefully you understand the gist of this. What we're trying to do here is, if we go back real quick to this one, we're trying to identify if it is a random sample. If it's not a random sample, then the statistical data that comes from it is invalid. It's not something that we're able to use. It's not a good source of information. And so we want to know whether or not it's a random sample. And that's why we went through and identified each scenario here, whether they were a random sample or not. With that information, if it is a random sample, we can do a lot of different things, but the very first thing is population inferences. Once a sample has been collected from the population, an inference about the entire population can be made by setting up a proportion. These inferences can be used to compare different populations and make predictions. So what that means is, if I get a random sample, based off of their results, I can figure out what the entire group is going to want, or I can figure out what's going to happen in the scenario based off of my random sample. Now, if it's not a random sample, then it's not going to be a true picture of the group. Just like that example where they were selecting only the kids from the choir class. If they said, hey, do you like music, and they only surveyed people in the choir class, then it might say like 80 or 90% of them, or even 100% of kids like music. So then you would make an inference, and the inference would say that, 100% of our kids at the school like music. But that's not true, because it wasn't a random sample. You're only asking people that like music. And so it kind of messes up your data. But if I go into this one, where we had that information and we make those predictions, we can go ahead and use this information to do the same thing. So it says Eastside Middle School conducted a survey of randomly selected 6th graders to determine which elective they were most likely to participate in. The results are shown in the table. So we have 14 6th graders selected Spanish, 20 selected theater, and 6 selected art. How many students were surveyed? Well, I would go ahead and add those up, and I would get 40 total students. And just for my reference, I'm going to go ahead and include that up here, so that way I can remember it as we go along. And then it says, what percentage of students surveyed selected Spanish as their elective choice? Now, if you remember, way back in Chapter 3 and Chapter 4, we started proportions, and we tried a proportion equation, and that was line equals line. And if you don't know what that means, I'm sorry, it's something that I taught this year. But for those that don't know, we go ahead and take the amount, which in this case the Spanish students was 14. We divide it by the total amount of students, and we set that equal to percent over 100, which we don't know the percentage, so that's why we include x. And then we set up our cross product. We cross multiply the numbers we know, and we divide by the leftover. So that'd be 14 times 100 divided by 40. And I'm going to write it as x equals 14 times 100 divided by 40. I then take that cross product, I multiply and divide, and I'm going to get x equal to 35%. So that means that we have 35% of the students surveyed selected Spanish. Now, I could take that a step further and find how many actual students that is, but the question doesn't ask for that. If I did want to know how many students that was, then I would go ahead and take that, instead of saying out of 100, I would say out of 350, because in the next one it says there's actually 350 students, but that's something that we'll do eventually. But letter C here, it says the school estimates that there are actually 350 students in the 6th grade. Using the sample, about how many students can you expect to sign up for art? So I do the same setup. I'm going to set up a proportion, but it's going to be 6 here instead of 14. So I go 6 divided by 40 equals, and that's going to be x over 350, because we know the total population of students. We're not asking what's the percentage. We're asking how many students actually signed up. I then set up my cross product by multiplying the things that I know and dividing by the leftover. So I multiply 6 times 350 divided by 40, and I'm going to get a grand total of x equaling 52.5. Now, you can't have 0.5 of a person, so we're going to round in this case, and we're going to go ahead and say there's about 53 students that will sign up for art. Okay, next question. The school estimates that there are actually 350 students in the 6th grade. Using this sample, how many students can be expected to sign up for theater? Now, if we looked back up there at theater, or if we go back to the previous one, theater had 20 students, and that's out of 40 total. And since we have 20 out of 40, we want to know how many total students are going to sign up for theater in our population. So we set that equal to the number of students signed up over the number of total students. So we do our cross product, 20 times 350 divided by 40, and I'm going to set that up as x equals 20 times 350 divided by 40. I then cross multiply and divide, and I get 175 students. So that means that of the 350 kids, 175 of them are going to sign up for theater. All right, next question. The school decides to drop any elective that has less than 10% of the population if they have signed up for it. Miguel says since there are only 6 people signed up for art, it should be dropped. Explain why this is or is not correct. So even though this is a really small number compared to the other ones, 14 and 20, this is 6 out of 40 students. So Miguel is actually not correct. And the reason he's not correct is if I take 6 out of 40 students, that's 35%. And we talked about that earlier. And that 35%, if I multiply that instead of being a percentage and I do students, that means that of the 6 out of 40 students signed up for art, 15% of that is the actual sample. So that's above the 10%. And the reason we can tell that that's 15% is due to the fact that we can push that further into the population, and we'd say, hey, that's 15% of the population signed up for art. And if you want to know how to do that, we would go ahead and we would set up our problem like we did earlier, that 6 out of 40 equals x over 350. And you would notice that when you cross multiply and divide, you're going to get a larger number here. But more importantly, if this is 15%, this right here has to be 15%, which automatically is above the 10% that they're asking for. And because these are proportional, again, it might be difficult to comprehend, but this fraction means 15%. And this fraction over here, when we find the answer, will mean 15%, but it's above the percentage that we're looking for. All right, the last part here, whether they're true or false, we're going to base it off of the data that's here. And it says over half of the students at East Side Middle School will select theater as their elective. And it says over half. Well, if I were to look at the information, that's actually false. It's not going to be over half that will select it. The theater classes, they were 20 out of 40, and that's exactly half. And then the next one, combined Spanish art classes will account for 50% of the elective results. Well, if we look at the information, and I'm going to go back here for a second, if we look at this information, there's 14 in Spanish, 6 in art. That makes 20 total out of 40. That's exactly 50%. So I could go ahead and say in this scenario that that's actually going to be true. And then last but not least, 350 students. East High School has at least 120 signing up for Spanish. We've already talked about that one where we cross multiply and divide here, and we would get around 122 students that sign up for that. Okay, I hope this was helpful for you. If you have any questions, let me know. And please make sure you submit this assignment and any other assignments on Schoology so I can get those graded. Hey, have a great day and stay healthy and safe.